Hello again. So this is the tip number 10 in which we are going to discuss some circuit analysis methods. So far we have discussed two methods in our videos. The first one is the mesh current method, okay, or this one is also called the loop analysis method. Similarly, the other method we have used in our circuit analysis problem was the node voltage method, or this one is also called the nodal analysis. So in most of the problems in our book, we are given that you have to solve the specific circuit by using a certain type of the analysis method. But if a given circuit is unknown and we have to find the quantities by using the feasible method, which we have to choose ourselves, which method will you guys choose for yourself? Okay, so now as we have two methods here, so it always depends upon the circuit which you are going to solve. So suppose we have a circuit here. So a circuit here we have is this one. This is the circuit, okay, and here we have a resistor here. Let me draw it again. Okay, so this is basically our circuit in which we are given a current source here of, let's say, 5 amps. This is 1 ohm, 2 ohm, 5 ohm and 10 ohm. Okay, and we are asked to find the voltage across the 2 ohm resistor. So we are not told that which method we are going to use here or which method we have to use. So it is up to you that you have to decide that whatever method is feasible for this circuit. So first of all, let us say we are going to use the node voltage method. So in using the node voltage method, here we have this node, and after finding out all the equations here, we will find the value of V1, and the value of V1 will be equal to V0, and we will have only one equation in node voltage method. We will have only one equation, and by solving that equation we will get the value of V1, which will be the feasible solution. Similarly, if we have to use the mesh current method, what will we do? We will use two currents here. The first one here will be I1, the second one here will be I2. So the value of I1 is already given here because this is the branch current in which the same current I1 is flowing, and the value of I1 is 5 amperes. Okay, so after going through all of these steps, we will have to find out the value of I2, and after finding the value of I2, what we have to do? We have to multiply the value of 2 with I2. Sorry, this will not be the I2, but as the direction of the current is here, so here it will be I1 minus I2, that would be equal to the V0. Okay, so here we can see very easily that the node voltage method seems very feasible to be applied here in this circuit, but it is not always the case. So suppose we have another type of circuit here. We have another circuit here like this one. Again, a branch current has been given. Okay, and the current here is, let me call it I1, and the value of I1 is, let's say, 10 amps. The value here is 5 ohm, 10 ohm, 2 ohm, 5 ohm and 20 ohm. I'm not writing the omegas with these quantities because it is already understood that these are the resistances here. So in order to avoid the confusion here, I have mentioned it. Okay, so let us first use the mesh current method. So in using the mesh current method, we can easily see here that we have to identify the meshes here. So this is the mesh number 1, this is 2, and this is 3. After identifying the meshes, we have to suppose the currents in these meshes. So these are the 3 currents, and we can easily again see here that very easily it can be seen here that the value of I1 is basically this, because the same branch current is flowing through this one, and that would be 10 amps. Okay, after finding it out, we will have to find out the equation for I2, then I3. So we will have some of equations of if we convert those equations into the matrices, so 2 by 2 matrices we will have, and solving the matrices of 2 by 2 dimensions will be easier for us. Okay, so that is the case when we have to use the mesh current method, because already a branch current has been given. Similarly, if we have to use, okay, so let me remove it. If we have to use the node voltage method, what will be the case then? So let me, this is 5, this is 2. Okay, these are the values here. So in finding the values here by using node voltage method, I'm presenting the node here by this red color. So how many nodes do I have here? I have 1, 2, 3, and this one, the 4 nodes here. Let me represent this one as a reference node here. So how many nodes will I have? This one will be V1, V2, V3. So then first of all, I have to use the node 1 and find the equation for node 1 here in terms of the voltage. Similarly, we have to find out the value or equation for V2, and similarly V3, and at the end, if we have to solve the equations by using the matrices, we will have a matrix of dimension 3 by 3. So it will be very difficult to solve the matrices of 3 by 3 instead of the matrices of dimension 2 by 2. Okay, so similarly, if that is the case with the equations, so the 3 equations with 3 unknowns will be very difficult to solve as compared 2 equations with 2 unknowns. Okay, so that is another case. Similarly, here, what is the takeaway here? Okay, so first of all, let us consider the takeaway here. So the takeaway here is that if you have some branch current given, so it will be always feasible for you to use the mesh current method. Okay, mesh current method or loop analysis is always feasible if the branch current is given. Okay, if the branch current is given. Similarly, another scenario occurs. Let me consider another circuit here. So to give you more examples here, this is another scenario in which we are given a circuit like this one. So that is the voltage source. Let me have it 5 volts. This is 20, this is 5, this is 7, this is 8. So again, we are not given the method with which we have to solve the circuit. So let me consider the mesh current method here again. So in solving the circuit by using the mesh current method, again we have to identify the number of loops here. So this is number 1, this is 2, this is 3. So this will be current I1, this will be I2, this will be I3. Again, there is no branch current given here. We will have a system of equation which will be composed of 3 equations with 3 unknowns, and similarly, if we convert those equations into the matrix form, we will have 3 by 3 matrix here, which will be a fat matrix. Okay, similarly, here we have to, what we have to do, we have to solve for I1, I2, I3, and that will be somehow difficult. Similarly, if we have to apply, let me apply the, okay, let me apply the node voltage here. So in using the node voltage here, I have to identify the node. So this is the node 1, this is 2, this is 3, and this whole is the node number 4. So let me again consider this one as the reference node. Similarly, these are the nodes where we have to find the voltages. Okay, V1, V2, V3, these are the nodes. So in solving this circuit, we can very easily see that the voltage of at these two nodes are already given. So the value of voltage here is V1 and the value of V1 is 5 volts. Similarly, the value of V3 is short circuited with this reference node, so the value of V3 is 0 volts. Okay, so here we just have to find the value of V2 by using the equation which we will form in terms of all the currents. Okay, so here we will have to find out the value of V2, and here we will have just one equation and one unknown, and solving the same problem with 3 by 3 dimension matrix is now very easier by using the one equation and one unknown. So it always depend upon the method which you are going to prefer. So if you are given any branch voltage here in any circuit, if branch voltages are given, if branch voltages are known, it is always feasible to use nodal analysis. Okay, so that is the takeaway from this circuit. Similarly, another scenario here is that it always depend upon the selection of your reference node. Okay, in any circuit you have to see that whether the selected reference node is making my problem easier for me or is it making it harder. So in many other situations, in many other circuits, it will be your duty to select the reference node. It is not always the case, because we can see in our problems that in most of the problems we have selected a reference node in which with which most of the branches were connected, but you shouldn't follow the same convention if the same convention is making the problem harder for you. You can use any other node here if the same node is making the problem easier for you. Okay, so that's it for today. This is the tip number 10, and I hope it will make your life easier while solving many type of circuits. So that's it, and I will see you with the next tip. Thank you so much and take care of yourself.